Okay, our last question today. An airplane trip involves 3 legs, so with 2 stopovers. So the first leg is due east for 620 kilometers. So let me just first draw that compass again. So north, east. Now we can draw out the scenario. So due east. You could do a scale model if you want. It's going to be a bit big this time though. So there's our first one. And from there it says the second leg is 440 kilometers, 45 degrees southeast. So just 45, so halfway between. And our last one, the third leg, is 50 degrees south of west for 550 kilometers. Okay, so just an approximation. So I have the general idea of the final position. Somewhere southeast. So we are trying to find out what is this vector. I'm going to add in some arrows. Okay, so you know this one is 620 kilometers. This one is 440 kilometers. And this one is 550 kilometers. Again, we can use that table method, or we can just do it directly on the diagram, whichever one works for you. I will just do both, though, since this is for practice. So here's a table. X and Y. We want to know what is V1, what is V2, what is V3, and then we're going to add up all those numbers together to find out what is the resultant vector, V. First one's easy because we know it's in the x directions, east or west. Don't have to worry about it. It has no north or south components, so I know this is going to be, I think of right as positive and up as positive. So this is 620 kilometers right here, and it has 0 y component. For this one, I know that V2 has an x component, so I can draw that dotted line right here and a y component. And this value right here is just going to be 440. So 440 cos 45 degrees. This one is going to be 440 sine 45 degrees. Know that for an isosceles triangle though, that the 2 leg lengths are going to be identical. So we type in 440 cos 45. You know the x and y components are just going to round to 311 kilometers. 311 kilometers. So I know that, okay, it has an x component of 311. However, the y component, be careful, it's going down, so I'm going to write down negative 311 kilometers. Now for our final vector v3, and it has an x component and a y component. So this one's going to be right here. This is 550 cos 53, because we're given this angle right here is 53 degrees south of west. So 550 cos 53. And we get 331 kilometers. So that's to the left. That's in the west direction. So negative 331 kilometers. In the y direction, it's 550 sine 53 degrees. So you get 4, 3, 9 kilometers. However, that is down, so I'm going to write down negative 4, 3, 9 kilometers. Now we can very easily see in the x direction, we first went 620 right, then 311 right, then we went back 333. So 620 plus 311 minus 331, we get a x value of 600 kilometers. So if I were to draw this x and y component for a resultant vector, that is 600 kilometers. In the y direction, we end up with 750 kilometers. Negative though, that's down. This is 750 kilometers. Now we can find out what is the hypotenuse and what is that angle. So again, a squared plus b squared. So the magnitude of our vector v is just going to be 600 kilometers squared plus 750 kilometers squared. If we square root that whole thing, so 600 squared plus 750 squared, square root, we end up with 960 kilometers. So for theta inverse tan, so inverse tan is going to be 750 over 600. Now make sure we're in degrees, not radians. This is talking about physics class, not math class right now. So our overall resultant vector is going to be 960 kilometers, and the angle it comes out to be is 51.3 degrees. That's south of east.